Okay, we're going to cover the last topic in algebra, which is functions. This is probably one of the topics that I get asked about the most when people are asking me about SAT questions they've seen. Functions come in lots of different forms in the SAT, but all of them are going to require you to follow directions. So one of the ways that they're going to present functions on the SAT is they're going to make up a math term that you've never heard before. But they're going to define the word, so all you need to do is follow the directions given by the definition of the term. So for example, the prime component of an integer, so that's the made-up word, prime component, there's no such thing. The prime component of an integer is defined as the sum of all the prime factors of that integer. What's the prime component of 39? So you would first break 39 down into its prime factors, which are 3 and 13, and then find the sum of those, 16. That's all there is to it. So you just need to read the problem for the definition of what prime component is. So that's one way that they'll present function problems on the SAT. Another way is they'll designate a function using a weird-looking symbol. So in this example, for any integer t, bracket t. So when they put t in brackets, this is what they want you to do with what's in the brackets. So bracket t means that take what's in the brackets, take t, square it, and add t. So in this example, we're doing bracket 4 minus bracket 3. So what this is telling me to do, for bracket 4, it's telling me to do 4 squared plus 4. And for bracket 3, it's telling me to do 3 squared plus 3. And so if I work those out, this is 20, this is 12, and 20 minus 12 is 8. So this bracket symbol around letters, that's not an operation that we define, like a square root or, I don't know, a square or something like that. But they're telling you what the brackets mean. Okay, the brackets mean to square the number and add it to itself. And then finally, they may actually use mathematical functions indicated by f of x. Okay, so if f of x equals this, what's the value of f of 4? You just need to remember that in this notation, they've replaced x with 4. That's your directions. That's telling you what you need to do in the expression on the other side. You need to replace the x's with 4s. So here you can see if you do that, if you work that out, replacing each of the x's with 4s, and you've got a calculator, you can actually just type it in, you'll get 60. Which brings us to quick quiz number 5. And there's 3 problems here. One easy, one medium, one hard. So take about 5 minutes to work through those, and then we will go over them. Okay, so we're going to go over these questions real quick. So the first one, the easy, uses the function notation that you're used to from school. This is a good one to practice plugging in on. This is not asking you to plug 21 in for x. It's asking you which of these, when you plug it in for x, will give you 21. So which number, when you plug it in here for x, will give you 21. So if you plug in answer choices until you find the right one, it's going to be 3. Okay. Because 2 times negative 3 squared plus 3 is 2 times 9 plus 3, which is 18, plus 3, which is 21. Remember that when you square a negative, it turns positive. So it's okay for our x to be negative, even though we're trying to get positive 21 because of the square. Okay, this one is using one of those function problems where it's got these weird symbols. So you're going to have a plus b in brackets means a squared minus b squared. So if we see x plus y in brackets, that means x squared minus y squared. And then this goes back to the factoring that we talked about yesterday. On the top, that's a difference of two squares, and that will factor into x plus y and x minus y. So you got to be able to recognize that when you see a difference of two squares. And just like we talked about yesterday, if it's not factored and you factor it, that should lead you to your answer. So if I factor the top, I can see I can cancel out the x plus y's, and that leaves me with x minus y. B. Okay, the last one. The height of the steam burst of a certain geyser varies with the length of time since the previous steam burst. The longer the time since the last burst, the greater the height of the steam burst. So if T is the time in hours since the previous steam burst, and H is the height in meters of the steam burst, which of the following could represent the relationship between T and H? So this says, the longer the time since the last burst, the greater the height of the steam burst. Okay, so if T is the amount of time in hours, which one's going to give me a greater amount as I increase T? So what I would do here is pick a couple of values for T. I'm going to pick like 2 and 5, and plug them into each of the answer choices and see which one makes the height go up. So on the first one, or I guess actually I should pick something that I can subtract 7 from, since a lot of these have that. So I'll say 9 and 12 instead of 2 and 5. Okay, so if I plug 9 in, 9 minus 7 is 2, and half of 2 is 1. If I plug in 12, 12 minus 7 is 5, and half of that is 2.5. So that one I increase T, and the total amount goes up. If I plug in 9 on the second one, I get 1, and if I plug in 12, I get 2/5. So it's not the second one, because increasing T decreases H. Alright, the next one, if I plug in 9, I get 2 minus 2, which is 0. If I plug in 2.5, I get 2 minus, what is that? I don't think right now. 2 minus a negative 5, so that'd be 7, right? So that made it go up. If I plug in 9 here, and then I plug in 12, let's see, if I plug in 9, I get negative 11, and if I plug in 12, I get negative 15. That went down. And then the last one, as T gets bigger, that's going to get smaller. So it's either A or C. Oh, I'm sorry. Down here, I messed this up. This doesn't go up either. If I plug in 12 right here, 2 minus 5 is negative 3. So that one also went down. This is the only one where increasing T will also increase H. Basically, what you want to do is just pick a couple of numbers for T, plug them in, and see what you get for H. This is what I got on answer choice A, answer choice B, answer choice C, answer choice D. On this one I would get 2 over 63 and 2 over 84. So the only one where H actually went up was here. This is going down, this is going down, this is going down, this is going down. Right? So that one's pretty tricky. And that one's mainly in functions just because of the function notation. So that's it for algebra. Next week we'll cover geometry. And then SAT.